Hi children, very good morning. So, we completed the chapter statistics, total statistics concept we will learn. I hope you worked out 9.1 and 9.2 exercise problems. Only in the statistics, only there will be 2 exercises. So, I give the full concept for the exercise 9.1 and 9.2. So if you go through the concept, it is very easy to solve 9.1, 9.2 exercises. I hope you clearly understood. Today, let us go for from another topic, that is elements of geometry. What chapter? Elements of geometry. Elements of geometry. It is a very simple topic. It is only one class. It is only 45 minutes class. This is small topic. Elements of geometry. You know what is geometry? You know that geo means earth, metron means measurement. The word geometry is derived from the Latin word geo. Geometry. Geo means earth, metron means measurements. So earth measuring. Okay, earth measuring geometry means. Geo means earth, metron means measurement. Earth measuring. So that only meaning is there. It consists of here in itself. So the geometry has a vast meaning. That is, what are the elements? Elements means the things, the objects. What are the objects? What are the things involved in the geometry? Elements. Anything is the element. Anything is the element. Element means the things available in the source. Okay. So, in the outside, in the external, what are the elements? The human beings are the elements. All movable things. All movable things, or maybe mobile or non-movable things, or elements. In the classroom is there. In the classroom, what are the elements? Benches, chair, table, these are the elements. Blackboard, fan, tube lights, LED lights, these are elements. Elements means the objectives. Elements means objectives. So let us discuss this is what it is? Board. How is the blackboard? The smooth surface. Smooth surface. What it is? Smooth surface. It is called plane. It is called plane. What is plane? What is plane? Plane is a smooth surface. It is one element. Plane is a smooth surface. Table is there. Table. The surface of the table. The surface of the top of the table. The surface of the top of the table. The surface of the wall. The surface of the wall. This all, it is called plane. It is called plane. What is plane? The surface is plane. What is plane means? The surface of the paper, sheet of the paper, the surface of the top of the table, the surface of the smooth top of the blackboard is all surface. It is limited. It is only limited. Surface is a limited. Plane is this. Totally comes to plane. It is a plane. Plane. So it doesn't have any definition for plane. Define the plane. We cannot define. We cannot define. The plane cannot be. Plane cannot precisely be defined. It is undefined. Point. This is point. Point means keeping a dot on the board. Keeping a dot on the sheet of the paper with the help of the tip of the pencil. Tip of the pencil. This is dot. This is dot. This is called. It is no measure for dot. No measurement for the dot. No measurement for the point. Okay. So generally these are denoted by points are denoted by capital A, B, C, and so on. This is a plane. We know plane. Smooth surface is a plane. Plane is extended. All 4 directions. All 4 directions. Plane can be extended in all 4 directions. Plane. So, surface over, plane over. The point also cannot be defined. Point also cannot be defined. Line, this is a line, you know that line. So the line with this line, it can be extended indefinitely. One line will have only starting point only, no ending point. Where it ends, you don't know. It can be extended indefinitely. So this is a line. This is the line. We can find out so many points uniformly on the line. We can mark so many things on the line. We can mark. We can point out. We can mark many points, as many points on the line. So point, line, and plane. Plane, point, line. These three are the elements. These three things, these three objects are elements. They cannot be defined. They cannot be defined. So the things that cannot be defined are called undefined terms. Undefined terms. Plane, point, line cannot precisely be defined. Precisely be defined. That is why they are called undefined terms. Undefined terms. So geometry is originated from the need for measuring land. Geometry is originated. How the geometry originated? How it has come? The geometry is originated from the need for the measuring the land. For measuring the land, to measure the land, geometry is formed. How it is originated? The geometry is originated from the need for measuring the land. So it was studied in various forms. The geometry is studied in various forms in every ancient civilization. In ancient civilization, you might have studied, you might have heard about ancient civilization like Egypt, Babylonia, China, India, Greece, etc. in the social studies. You might have heard about the ancient civilization in Egypt, Babylonia, China, India, Greece, these all. So in those civilizations about geometry really studied. So the Egyptians developed a number of techniques and rules. The Egyptians developed and studied a number of techniques and rules for calculating a simple area. Simple areas. For example, land is there. The land is in the form of square. The land is in the form of the square. Then what do you use area? How do you use? Side into side. Side into side you use. The land is in the form of rectangular form. What do you use? The area is equal to what? L into B. L into B. Like this, the Egyptians developed a number of techniques and rules for calculating the simple areas. In the Indian subcontinent, the excavations at Harappa and Mohenjo-daro, etc. So many, they invented so many things. So that Indian Valley civilization made extensive use of geometry. So in ancient India, Sulaba Sutras were the manuals. In ancient India, Sulaba Sutras are the manuals of geometrical constructions. In ancient India, what are the manuals of geometrical constructions? Sulaba Sutras are the main manuals of geometrical constructions. Okay, in ancient India, what are the main things? What are the main manuals of geometrical constructions? Sulaba Sutras are the main manuals of geometrical constructions. So, in all these civilizations, Egypt, Babylonia, and Harappa, Mohenjo-daro, these all civilizations, geometry remained a practical-oriented discipline. But in civilizations like Greece, other than Egypt, Babylonia, Harappa, Mohenjo-daro, in the Greece civilization, but in civilizations like Greece, the emphasis was on the reasoning. But In Greece civilization, what is the importance? In what concept they emphasize and stress is reasoning, giving the reasoning also they emphasize Greece civilization. Okay, other than Greece civilization, did not emphasize, they did not stress, they are not highlighted anything. So in this Greece civilization, geometry was emphasized for the reasoning. So Thales, a Greek mathematician, gave the proof for the first time. Proof. How you got? I told you, area of the square, side into side. How you got it? The proof. How the proof has come. What is the area of rectangle? The formula for area of rectangle is L into B. How the proof is made? The perimeter of rectangle 2 into L plus B. How the proof came? How you got 2 into L plus B? Such proofs are made by Thales mathematician, is a Greek mathematician, Thales. Okay, it's the first time. The Thales, a Greek mathematician, gave the proof for the first time. The Pythagoras was there. You know about Pythagoras. You know Pythagoras theorem. In right angle triangle, use the Pythagoras theorem. The square of the hypotenuse is equal to sum of the squares of other two sides. You know that Pythagoras theorem. This is the right angle. What is this? Right angle. The right angle is situated at B. So what is the hypotenuse? The side opposite to 90 degrees is called hypotenuse. This is the other two sides. So square of the hypotenuse. What is the hypotenuse here? AC is equal sum of the squares of other two sides. AC square equal to AB square plus BC square. So you know very well about the Pythagoras. He was the disciple of people of Thales. He was the student of the Thales. The Pythagoras was the student of Thales mathematician. So he discovered and developed. The Pythagoras discovered and developed a theory of geometry extensively. So this process is continued till 300 BC. So next Euclid. About Euclid also you know that. Who is Euclid? Euclid. Euclid was the father of the geometry. Euclid was considered as father of geometry. Who was the father of geometry? So Euclid was the father of geometry. Euclid, mathematician, considered as father of geometry. Okay, so we say Euclid is the father of geometry. So after that, what did he do? Euclid, he written some books. He written some elements. And they are divided into 13 books. How many books? 13 books. Euclid written some elements. Some elements are written by Euclid. It consists of 13. Each one is called book. So Euclid elements contain how many books? 13 books. The Euclid, some elements are written by Euclid, which consist of 13 books. So in Euclid elements, how many books are there? 13 books are there. Euclid elements consist of dash books. 13 books. Okay, like that. So let us divide into 13 chapters. Let us see one by one here the things which are involved in elements of geometry. Now we discuss. Children, next Euclid's definitions. Euclid's definitions. Euclid definitions and games and postulates. Let us see. Euclid definitions and games and postulates. What are the important points involved here? You know, everybody knows that this is a duster. Suppose the wooden duster is there, Otherwise, the box is there. This box was there. This box is a solid. It is a solid. A solid means it contains length, breadth, height. So the blackboard is there. Its surface. Surface means 2 dimensions. Surface will have 2 dimensions. And line is the breadthless length. A solid has shape. The thing The object which has shape, size, when it can be movable from one place to another place, it is solid. Okay, it can move from one place to another place. It has some boundaries. It has some boundaries. This is solid is here. It has some boundaries. This boundary, this boundary, this boundary. All four boundaries will be there. So these boundaries are called surfaces. For example, a solid. It has this. It has the surfaces. This one surface, surface like this. So every solid will have some surfaces. So every surface will have some dimensions, 2 dimensions, length and breadth. So a solid has 3 dimensions, that is length, breadth, height. A solid has 3 dimensions. A surface means 2 dimensions. Surface 2 dimensions. A line has only 1 dimension. Line has 1 dimension. Point, no dimensions. A point has none. A point has none. Surface will have 2 dimensions. For example, rectangle. The rectangle is 2 dimensional figure. Okay. The object, a solid which contains only 2 dimensions is 2D objects, 2 dimensional objects, 3 dimensional objects, 3 dimensional objects. Okay. 3 dimensional objects means cube. These are 3 dimensions. What are those? Length, breadth, and height. Rectangle is 2 dimensional object. Only 2 measurements, length and breadth. Square also same thing, 2 dimensional object only. Isn't it? So, that is, surface will have 2 dimensions, line only 1 dimension. A line will have only 1 dimension. A point will have only no dimension. Point, no dimension. Point, no dimension. These 3 are called undefined terms. What do you call? Undefined terms. What are undefined terms? Undefined terms means the terms that cannot precisely define. The terms which cannot precisely define, precisely are called undefined terms. Undefined terms are what? Point, surface, point, plane. Undefined terms: plane, point, line. These are undefined terms. With help of undefined terms only, we can define the defined terms. No undefined terms, no defined terms. Okay, point. For example, if you want to start the line, so how you start the line? From initial point, like this. So initial point means point. No point, no line. No point, no line. If you want to draw the plane surface, this is plane surface. See, we need the dimensions, length and breadth. Point. Anything you want, the point should be there. So the plane and in the plane only you can define the surface. In the plane only you can surface, you can define the 2 dimensions or 3 dimensions, 4 dimensions, 3 dimensions. So without undefined terms, no defined terms. Therefore, plane, point, line are the undefined terms. Why they are undefined terms? Means they cannot precisely be defined. That is why we call them as undefined terms. Plane, point, line. Okay. Now, a point is that which has no point. What is point? What is point? Quickly definition. What is point? A point is that which has no point. The thing which has no path is called point. And line, what is line? A line is breadthless length. A line is breadthless length. What is line? A line is breadthless length. Breadthless length. And this is a line. The ends of the point, the ends of the lines are points. The ends of the line are points. The ends of lines are points. A straight line is a line which lies. A straight line is a line which lies evenly with the points. And the straight line we can mark so many points. A, B, C, D, E. This is a line here. So even you can mark the points on the line. And a surface is the top which has length and breadth. What is surface? Which has length and breadth, two-dimensional. The edge of the surface, for example, the blackboard is there. What is the edge of this? Is a line. The edge of this surface, this is corner. So the edge of surface are lines. The edge of surface are lines. The edge of the table or bench are the lines like this. Okay. The edge of the book. The edge of the book is the line. The edge of the book is line. And when you fold the paper, when you fold the paper, this line will get. When you fold the paper, the crescent of the folding paper, So when you fold the paper, we got this. See children very clearly. When you fold the paper, in the middle of the paper we got a crescent. Crescent means a mark. This is called line. This is called the line. The crescent of the paper. When you fold the paper, we get the crescent. That is a line. I hope you understand the line definition. So a line cannot be extended. Line can be extended indefinitely. A line can be extended. There is no end. There is no end for line. Line, if we keep on, we can extend the line evenly. So these are the definitions by Euclid. A plane surface is the surface which lies evenly with the straight lines on itself. So, therefore, a point, line, and plane are the undefined terms. And one more, what we discussed this all the definitions. Undefined terms we discussed. Now, angioms. What is angioms? Angiom means it is a statement, self-evident statement. Self-evident statement is called angiom. Self-evident statement. What is self-evident statement? We make our own statement which satisfies the things. So the sun rises in the east. The sun rises in the east. It should be accepted by the universal. It should be accepted by the universal truth. The sun rises in the east. This is the axiom. This statement is doesn't need any proof. It doesn't need any proof. How can you prove that? Prove that the sun rises in the east. Prove that the sun sets in the west. How can you bring the proof? For the such statements, no proof. Such statements are called angioms. What is called? Angioms. What are angioms? What are angioms? Angiom means self-evident statements are called angioms. Self-evident statements are called self-evident statements are called angioms. Understand? I hope you clearly understood about the angiom. What is angiom? The statement which has no proof. Which has no proof. The statement which has no proof, no evidence. Self-evident, no self-evident statements. They need not to be proved. Such statements are called what? Angioms and postulates. So with the help of the angioms, we make the postulate. Postulate means that also nothing but angiom only. Angioms or postulates are the assumptions. Angiom means assumption. Assumption means assume, imaginary, suppose. Okay. So angioms and postulates are the assumptions which are obvious universal truths. They need not to be proved. Euclid angioms. Euclid. What are the Euclid angioms? Now Euclid angioms. Euclid's angioms. The first one is things which are equal to the same thing are equal to one another. Things, the first angiom of Euclid is things which are equal to the same thing are equal to one another. Things are there. A equal to B equal to C are there. So when A equal to B equal to C, A equal to C or A equal to B or B equal to C. A, B, C are equal to one another. A, B, C are equal to one another means A is a friend of B and A, B, C are the friends. When A, B, C are friends, A is the friend of B and C, B is the friend of A and C, C is the friend of A and B. So this is Euclid first angiom. Means things which are equal to the same thing. When A and B equal to C, A, B are equal to C means A equal to C, B equal to C. Okay. A equal to B. A, B are the friends of C. A equal to B. A and B friend. A is the friend of C. When A is the friend of C, B also becomes friend of C only. When the things are equal to the same thing, are equal to one another. equal to one another. A equal to B equal to C. A equal to B equal to C means A equal to C, B equal to C. Okay, like that. X equal to Y equal to Z means X equal to Z, Y is equal to Z. Y is equal to Z. Things which are equal to the same thing are equal. X and Y are equal to Z means they are equal to one another. X equal to Z, Y equal to Z means X equal to Y. If A equal to 2, B equal to 3, AB equal to C. Like this. When A, B, C are equal, A equal to 3. The same things which are equal to the third, the two persons are there. When the two persons are equal to third one, when A, B equal to K, A equal to B equal to K, these two are equal to K, then A equal to B. A equal to B. Like that. The things which are equal to the same thing, they are equal to one another. Second postulate is, second axiom is, if equals are added to equals, the wholes are equal. If equals are added to equals, the wholes are equal. For example, X is there, here Y is there. When you add 2 here, here also add 2. Then X plus 2 equal to Y plus 2. If X equal to Y, if X equal to Y, X equal to Y, whatever add to the X, same thing should be added to Y. Whatever change you bring in the X, same change you bring in the Y. Then that is the Euclid's second axiom. The adds, if equals are added, if the equals are added to same, the wholes are equal. The wholes are equal. The wholes are equal. If equals are added to equals, if the equals are added to equals, the wholes are equal. Third one, if equals are subtracted, x minus 2 equal to y minus 2. If x equal to y, both sides if we subtract minus 2, the x minus 2 equal to y minus 2. If x equal to y, automatically x minus 2 equal to y minus 2. Like that. So, things which are coincide on one another equal to one another. For example, this line is here, this line. On this line, this is one more line is there. One more. This line is here, this line is here. These two lines are coincide. Coincide means one over the other, one over the other. When the two lines coincide, they are equal to one another. The two lines are coincide. For example, the textbook is there. In this notebook, the papers are coincide. Coincide means one over the other. All pages are equal. All pages are equal. So when you palms, for example, the palms are there. Just you close, bring your palms together and close them. So when they coincide, when they are coincide, these two are coincide. One over the other, exactly occupy the same position. No up downs, no upside downs here. Exactly they coincide. Then they are equal. Then they are equal. That is the third one. So that is fourth one. Things which coincide with one another equal to one another. The whole is greater than the part. Whole is greater than the part. For example, the whole thing is there. In this A, B, C, D, E. The whole part is what here? You started with A and end with E. A. The whole part is AE. This is the whole. This is what? Whole. Remaining are parts. A, B, B, C, C, D, D are the parts. D are the part. The things. The whole is greater than the part. AB is the part of the total whole. What is the whole length? A is the whole. So AB is the part, BC is the part, CD is the part, D is the part. The part is so the whole is greater than, the whole is what? AB. The whole is greater than AB, BC, CD and DE. The whole thing is always greater than the part. The things which are double. The things which are double, for example, x equal to y is there, x equal to y. Things are double, means multiply with 2x equal to 2y, like this. So the things which are double, the same things are equal to one another. When x equal to y, when you double them, then becomes 2x equal to y. When triple them, 3x equal to 3y. So the things which are halves, for example, x equal to y is there, x equal to y is there. When you make it half x equal to half. So, whatever you are bringing the same change on the both sides, x equal to y are there. If you want to multiply with half on both sides, okay, half x equal to half, 3x equal to 3y, 4x equal to 4y. So, like this, whatever change occurs in the left side, same change occurs in the right side, then they are equal. So, if you want to bring anything in the one side, you should bring the same change on the both the sides, then they are equal. These 7 are the Euclid angles. Things which are equal, the same thing are equal to one another. Second one, if equals are added to equals, the wholes are equal. If equals are subtracted from equals, the remainders are equal. Fourth one, things which coincide with one another, the equals one another. The whole is greater than 1. The things which are double of the same things are equal to one another. The things which are halves of the same things equal to one another. These one are the Euclid angles. The Euclid angles are 7. You go through the textbook. In the textbook clearly mentioned. You go through it. I hope you understood. Next, finally, Euclid's phosphates. Euclid's phosphates. Angles over phosphates. Euclid's phosphates. Euclid's 5 phosphates. First one, a straight line can be drawn from only one point. A straight line can be drawn from one point only. A straight line can be formed from the one point. A straight line can be drawn from only one point to another point. This point to this point. A straight line can be formed one point to another point. Okay, here. Second postulate. A terminated line can be produced indefinitely. A line can be produced. For example, straight line is there. Like this, you can produce indefinitely. There is no end. Indefinitely means endless. Indefinitely means it can be extended like this. It can be extended indefinitely. This is the second postulate. A terminated line can be produced infinitely. So, when the limited line is still here only first. If you want, you can extend it. You can extend it like that. So, a terminated line can be produced indefinitely. Third one is a circle can be drawn with any center. A circle can be drawn with any center. No center, no circle. Without center, can you draw the circle? No. So, a circle can be drawn with any center, with any radius. With any center, with any radius. A circle can be drawn with any center and any radius. Next, the fourth postulate is all right angles are equal. All right angles are equal to one another. All right angles. This is a right angle. This is also right angle. This is angle A. This is angle B. So, angle A equal to angle B. All right angles are equal. All right angles are equal to one another. Next, the fifth postulate is if a straight line is falling. Fifth postulate. The most important postulate. Fifth postulate. The fifth Euclid postulate is if a straight line is falling on a straight line. If a straight line falling on a straight line, make the interior angles. For example, this is a straight line. These are the straight lines. On this